Welcome to Study Loop.
We need to find the sag of this wire from point A to point B, which is labeled in our diagram as this length h. And we also need to find the mass of this cable, which we can find by first finding the weight per unit length of that cable. So before we start the problem, we need to find these unknown values. So the length from B to C, we're given that the length from A to B is 90. So to get the length from B to C, we just do 90 divided by 2 to give us a value of 45 meters. And we do the same thing for the length in the x direction from point B to C. So we use the given length of 60 divided by 2, and we'll get a length of 30 meters from B to C. And we're also given that the tension, the maximum tension of the cable is 300 newtons. So we're going to first start by finding the length of the sag. So I'll start by writing out the following equation. So the length of the cable from point B to point C is going to be equal to C times the hyperbolic sine of x of BC divided by C. And we know what S of BC is. C is our unknown. And we know what x of BC is. So we can take this equation and solve for the unknown value of C. So we'll get that C is equal to 18.495 meters. And now the equation for y of b, that's going to be C times the hyperbolic cosine of x of bc divided by C. And we know what C is. We just calculated what C is. So we can plug in C and find the value for y of b. So we plug in C, should be the hyperbolic cosine. So the hyperbolic cosine of x of bc divided by C. And then this will give us a length of 48.651 meters. So to find the length, the sag of the cable, which is labeled as h, we do y of b minus c, and we know y of b and we know what c is. So the sag h, that's going to be y of b minus c, and this will give us a sag of 30.2 meters. And now we're going to find what the mass of the cable is. So the weight per unit length of the cable can be found by taking the tension of the cable and dividing it by the length, y of b. And in the previous part, we've already calculated y of b, and we know what this maximum tension is, since it's given by the problem. So we can write that the weight per unit length is equal to 300 divided by y of b, and this will give us a weight per unit length of 6.1663 newtons per meter. And so to find this, the total weight of the cable, we can take this value here and multiply by the given length of 90 meters of the cable. So the total weight, that's equal to the weight per unit meter times the length. So we plug in, then plug in the length, and this will give us a weight, 554.967 newtons. And to find the mass, we take that weight and divide it by the acceleration due to gravity. So now mass is equal to the weight, and then divided by the acceleration due to gravity. And this will give us a mass of 56.57 kilograms.